So hi, everybody. Thank you all for taking some time with us today to go through the new PowerMax platform. Quick introduction for myself. My name is Scott Delandy. I'm part of the product management team within Dell's Infrastructure Solutions Group. And as Mr. Walker mentioned at the beginning of the session here, longtime EMC and Dell storage resource. I actually started with EMC back in 1990, believe it or not. So coming up on 32 years with EMC and now Dell Technologies. A little bit of a fun fact, I joined in July of 1990, and the original Symmetrics platform was announced and introduced in August of 1990. So I actually get to hold one of the distinctions as being one of the few people still here that actually was with the organization before Symmetrics was even a thing. So it's been fun. And what I'm going to do is basically take you through the highlights around the new platform. There's a lot of things that we're introducing as part of new packaging, new functionality, new features. So we'll go through it and we'll try and get everybody done within the amount of time. Before I actually jump into the technical content, I want to just make sure everybody's aware of kind of the timing and the dates associated with the launch. So we externally announced the platform about a month ago at Dell Technologies World. So right at the beginning of May, we did the external announcement. So there's information available on the product, data sheets, some general material if you're looking to get some more details around that. A lot of the more technical details, white papers, knowledge, KTs, those are things that are going to be delivered as we get closer to availability of the platform. So, hold tight if you're looking to, kind of surf the web and find, kind of the white papers and things like that. So those haven't quite yet been posted. They're being finalized over the next couple of weeks. As far as the quoting and configuring and kind of sizing systems, those actually all went live on Monday. So we now have the ability. So if you are interested in getting an idea of what a configuration would look like, how it would be sized for a particular workload requirement, what would something like that actually cost, we can actually do that for you now as of Monday. So we can provide that level of detail. The ship date, what Dell refers to internally as RTS, ready to ship, is on July 19th. So we're just only a couple weeks away from being able to actually start to ship the platforms and start the transition from the current generation of platform into the next generation PowerMax. So a lot of work, a lot of effort went into that. Just to give you an idea, so you'll see this platform, this release has over 200 net new features that, from a product management standpoint, we're tracking. Some of those things are visible to the user, right? Those are like real features in terms of the new packaging around the drives, a new version of Unisphere. Some of those things are internal to the system that a user wouldn't necessarily see, but are very important in terms of providing improvements, whether it's performance, efficiency, serviceability, reliability, whatever. But as a result of those 200 new features, we've actually been doing QA testing within the platform. As of the ship date of July 19th, we'll have been in QA around the code and the hardware for over 14 months. So over a year, we've been doing testing within the engineering labs for all of the different features that are included in this release. The QA lab themselves has over 500 of the new systems. So it's a rather significant investment for the organization to get this release out the door. And just to give you an idea, 200 new features, there were over 16,000 test cases that were generated off of those new features that were being released. So we're feeling very confident in terms of what we're seeing as we get ready to go ahead and start to ship the product. Pretty much all the programs in terms of our quality, reliability, serviceability metrics are all green. So we're pretty happy with the effort that's been put forward to make sure that we can get this product out to you guys by the summer timeframe. So with that said, here's the agenda for today's discussion. So we'll start off by taking kind of a quick highlight look at all the kind of the big things that are new with the platform. So what are some of the key changes or improvements that we made with respect to PowerMax? And then we'll get into the actual hardware itself, because you'll see there is some changes in terms of kind of the packaging and the different components and how we lay those components out on the storage platform. You'll also see that we've evolved some of the terminology that we use to describe different components within the system. So for example, what we used to refer to as an engine, we are now referring to as a node pair. What we used to refer to as a disk enclosure, a drive DAE, a drive array enclosure, we now refer to as a dynamic media enclosure. So again, there'll be some new terminology that we'll cover as we go through this. So we'll take a look at the packaging highlights. We'll take a look at what's new from an efficiency perspective. There are a lot of things, again, that as I mentioned, that are kind of significant changes with respect to the platform. Some of the things that we'll look at is the new RAID implementation, or the way we're doing parity across the system. So we're moving into a new Flex RAID that has a lot of advantages for us within this platform today, as well as very important to us going forward, especially as you see higher capacity media options become available, and wanting to be able to do things like single drive upgrades in order to expand the system. One of the other changes that we'll talk about is the way that we're doing kind of our metadata management. We've got a new cache design that we're introducing, where we're augmenting what had been DRAM cache by adding in persistent memory. So that significantly increases the amount of available cache or memory available within the platform. So that has a lot of benefits in terms of effective capacity, snapshots, how we manage things around the data reduction within the array. So there's a number of benefits there. Speaking of data reduction, there's some new algorithms, some new software features that we're introducing as part of the data reduction. So we're actually seeing higher data reduction rates with the new improvements. So there's some good things there. And there's also been some improvements around the reporting for data reduction, being able to more easily be able to identify the workloads that are data reduction friendly versus some of the things that aren't. So making it easier from an administrative perspective, kind of have an understanding of the different workload types that are being stored on the array, and kind of what the data reduction efficiency is for those different types of workloads. There's a lot of cool things happening around tech refreshes and data mobility. One of the things that a lot of users are very excited about within this platform is the new support to be able to do data in place upgrades going forward. So if I bring this system in on day one, or over the next several months, a year and a half, 2 years later, as that next generation hardware platform becomes available, one of the options you will have is to basically do a data in place upgrade, replace the nodes on an existing PowerMax system, and upgrading to the newer technology and taking advantage of the performance and the density improvements that we're planning for future releases on the hardware side, without having to do a data migration, without having to do anything at the host level to change mapping, masking, device presentations, things like that. So very simple to be able to move forward to new technology just by doing, again, that node replacement within the array. There's a whole bunch of things happening on the security side, so I'll touch on a number of the new features. What we're introducing is this capability to support what's referred to as a zero trust infrastructure. So the chipsets that we're now using on this platform specifically have a hardware root of trust built on those or enabled on those. And what that does is it basically gives us the ability to make sure that as we're installing the system, as we're loading code, as we're making software updates and software patches, all of those things are validated up against the hardware root of trust. So it's a way of really minimizing the potential exposure for a hacker to figure out a way to get backdoor access to a piece of infrastructure by either modifying the hardware itself or by putting in something within a piece of code that allows them to, again, be able to kind of sneak in beyond the firewall, but be able to get access to the system and potentially access to the data on the system. So we'll talk about that, where we see that going from just a general security trend within the technology space. We'll also spend a couple minutes talking about the new file capability. So we have a net new file software feature that we're adding into the platform. The code itself is actually file software that is currently being shared across the Dell primary storage family. It actually started life in the new mid-range platform, the Power Store, that was introduced a couple of years ago, and it was just recently launched on the software-defined platform, the PowerFlex. So what we're doing for the first time is actually taking file code, and rather than having 3 different products with 3 different, implementations around file, we now have a single file capability that we can leverage across the different platforms. So that gives us a lot of benefits just from a development perspective, from a product management perspective, because now you're not maintaining 3 separate code bases, you have a single code base. So it gives you a better ability to invest in new features and to continue to drive innovation within the file space. So we'll spend a few minutes kind of taking you through what's new with that and some of the integration points that we have specifically within PowerMax. So let me kind of summarize sort of the big things that are new with the platform, right? And I'll kind of go around the wheel here. First and foremost is just the massive improvement and increase that we've made in terms of the scalability and the density of the platform, right? So to put that into context, if I have a PowerMax today at 2000 or an 8000, I have an engine, right? And that engine has 2 directors, and it has 2 DAEs, 2 drive trays, and there's 24 slots on each of those DAEs, so it gives me 48 drives in these 2 directors. And that engine, the physical form factor for that engine is a 10U rack space, so about a quarter of the rack is used to put in a single engine with 2 DAEs. The new form factor for this system is a node pair, which is 3U, and then a node pair, which is 3U, and then a 2U 48 slot drive shelf. So we're doing 48 drives. There's actually 2 rows of 24 drives. So there's 24 and then another 24 behind that. That sits in a 5U rack space. So we've taken the physical density and we basically cut that in half. So that's point number 1. Point number 2 is we've significantly increased the amount of effective capacity we can fit into that 5U form factor. So in a 10U PowerMax 2000, 8000, I could get roughly about 500 terabytes of effective writable space, right? And any more than 500 terabytes, you'd have to add another engine in order to scale the capacity out. With the new design and the improvements that we made, mainly around the metadata management, that 5U dual node 48 drive system can now support over 4 petabytes of effective capacity, right? So we've increased the amount of capacity by 8x, and we've reduced the footprint in half. So if you do the math on that, it's roughly a 15x increase in the amount of capacity per U we can now support with the new packaging on the new system. So really, really significant change. The fact that you're looking at 4 petabytes of capacity now in a 5U rack space with the ability to scale that out and to be able to add more. We'll talk about that. One of the other new hardware features is this concept, as I mentioned, a dynamic media enclosure. And those are where the flash drives are installed. And what's different about this versus the packaging of the 2000, the 8000, 2000, the 8000, I had an engine, and that engine always had to have 2 drive trays with 48 drives or 48 slots. And when I added an engine, I always needed to have a minimum of 1 RAID group within that engine, because that's how we would scale the system. We just couldn't put an empty engine in place. The media enclosures basically disaggregate the front end node pairs from the actual storage capacity, the flash modules. So what that means is that I can now scale my front end node pairs independently of the capacity, the media enclosures off the back end. And I'm going to go into deeper detail and show you what that looks like and kind of the flexibility in terms of how you can mix and match different things. But it's a major improvement in the packaging, because now we can hit different performance and different capacity requirements. So if you need to build a configuration that has lots and lots of performance, and you need a lot of compute, you need a lot of connectivity, you just don't need a lot, or a lot of cache, and you just don't need a lot of capacity, we can now do that. We can scale out multiple node pairs on the front and have a minimal amount of capacity, a single media enclosure on the back end. And vice versa, if I need a whole lot of capacity, but I don't need a lot of performance, I can have a single node pair and I can build out the amount of media enclosures I can support on the back end. So again, it gives us a lot of flexibility that we just didn't have with that kind of modular building block approach that you had with the 2000, 8000 engine, and even with the VMAX systems before that, right? So a lot of flexibility there. From a connectivity perspective, we've simplified the I/O modules. There's basically two flavors that we support today. There's a 32 gig I/O module, and within that 32 gig connection, I can mix and match fiber channel, FICON, and SRDF over fiber channel, right? So I have 4 ports on an I/O module. If I had open systems in Mainframe, I could take 2 of those ports on that shared I/O module, connect that into the fiber channel SAN, and use those other 2 ports to connect into FICON if I want. So I no longer have to have protocol-specific SLIC cards like I need within the 8000 in the 2000 today. So there's some flexibility there. We also have a 25 gig I/O module that supports NVMe over TCP, so we can do block-based storage using NVMe as the protocol. We also support iSCSI connectivity, and we support file. We'll talk again about file and some of the changes that we made there. And we can do the SRDF piece over IP connectivity as well. The bottom of the wheel, so anytime upgrades, I'll spend a sec talking about that, but it's kind of straightforward, right? I've got an old machine, a new machine becomes available. I take the nodes off of the old machine, replace those with the new nodes, and I've just upgraded that system completely online, non-disruptively, no data migration, no host outage, no host changes in order to do that. So it really accelerates a user's ability to be able to adopt and move to that new technology, because you don't have to spend weeks or potentially months migrating the applications from the old frame onto that new frame. So again, simplifies the tech refresh process. From a DRR perspective, so I mentioned this already, so there's new compression algorithms that we've introduced in this release, and that gives us a higher level of compressibility. Roughly speaking, it translates into about a 20% improvement in data reduction as a result of the new compression algorithms that we're running. So if we were seeing about a 3.5 to 1 data reduction on a PowerMax 2000, 8000, just as an example, we should be seeing 4 to 1 or better with the new platform, just because of the improvements that we've made on the compression side. For the mainframe folks that are out there, we've also taken compression and we've enabled that for CKD devices as well. So we can now support compression for mainframe. And the testing that we've done, we generally see about a 3 to 1 compressibility. Now that assumes you're not already compressing at the mainframe host level. So you have uncompressed data being written down to the CKD devices. We can then take those CKD devices, run the compression algorithm up against that in line, and we can again reduce the space by about a third in terms of the data reduction. From a replication perspective, whole bunch of things there, probably a day to go through all the changes that were made, but just to kind of net it out, we've increased the number of snaps that we can support. So the current limit is 128,000. The new limit goes to 64 million, right? I feel like Dr. Evil, 64 million snaps. So, but it's actually an important number, and it supports a great use case around providing very granular snapshots, recovery points to protect against things like potential malware attacks or ransomware attacks. Where now, rather than creating snaps in several hour intervals, I can now create snaps in several minute intervals. So if something were to happen and I needed to go ahead and recover something, my recovery point objectives go from hours down to minutes. And in order to do that, I need to be able to support the scalability to support all of those snaps. If I want to kind of do those multiple snaps over the high frequency snapshots, it does require potentially millions. And I'll take you through some math and some of the use cases around that. For SRDF, increased the number of device groups, integrated support for file. If you're an SRDF user today and you're using SRDF in the block environment, you're going to love the SRDF integration for file. Very straightforward, takes advantage of all of the features around setting it up, failing over, failing back. So just like you would see a storage group in the environment today to manage up against SRDF or set SRDF up against, you now have a NAS file that behaves basically like a storage group. So very simple to basically integrate that in and extend what you might already be doing on the SRDF side for the block-based applications to now include the block and file-based applications. So some cool things there. We've got some things that we're doing with cloud integration, being able to snap off to cloud, as well as having a variety of options that once I've created that snap in the cloud, what can I do with it? How can I take that snap and how can I hydrate it into a block device and actually run applications up against it? Can do it in the cloud, can do it against the system that created the snaps, can now do it up against another system that has access to the S3 object presentation that's in the cloud. So we'll spend a second talking about that. And then last, and we used to lead with this, but there's so many other things. It's just the improvements in the hardware. So when you look at the chipsets and the interconnects and the improvements around software and microcode, you have a machine that gives you roughly about 2x the amount of IOPS per port versus the previous generation 2000, 8000. So a big bump in terms of performance from a throughput perspective, but also from a latency perspective, we've cut system round trip latency by more than half, right? So to get a cache hit out of the machine, whether it's a read or write into the memory, you're looking at a service time of less than 0.1 milliseconds or 100 microseconds. And to put that into context, a 2000, 8000, if I had an IO that was cached, a read hit or a write hit out of the cache, I was looking a little bit over 200 microseconds to do that. So what was 0.2 milliseconds in the old machine for that cache hit is now less than 0.1 milliseconds with the new machine. So some improvements related to the response time for the system. And that's, again, a result of faster components, higher bandwidth interconnects, a lot of, again, cleanup and improvement around the microcode for the array. So there's a nice performance story there. There's also a new version of Unisphere that's being introduced with the platform, so Unisphere 10. By the way, the code is now, instead of the it's now referred to, it's release 10 of the PowerMaxOS. So that's what the new array will ship with in terms of microcode. But Unisphere 10 has a whole bunch of new features that we're introducing. The one that everybody's interested in is the multi-factor authentication. So being able to log in as an admin on the array, but now having to authenticate using secure ID. So entering the 8-digit PIN, your username, your password, authenticating up against the secure ID. If you pass that, then authenticating up against the password protection built into the array. There's a bunch of things that we're doing around automation for workload planning and workload placement. So being able to look across a complex of arrays and being able to kind of do sort of a workload planner, not just as an individual array, but against the complex of arrays. So as in a multi-array environment, if you're landing new applications and you're trying to figure out, where's the best array from a resource perspective to size and move this out or place this application, this will be very helpful. It's also helpful from a load balancing perspective. So if I have one machine that's 80%, another machine that's 20% in terms of utilization, this will help you say, well, if I were to take these 3 or 4 storage groups off of the machine that's running hot at 80% and move those over to the machine that's at 20%, that machine will go here, this will go here, right? Again, help you kind of figure out what to move and where to move it and what the impact of potentially moving those applications would be from a resource perspective. There's a bunch of things that are being integrated around SAN health monitoring. One of the things that you'll see that's available is the ability to go in and look at the SAN fabric and help identify and remediate things like slow drain. So this is an issue that we've been seeing for a number of years now, and it's this idea that you have an array in a fabric that's at 32 gig from a fiber channel perspective, but you may have older hosts in the environment that still have 8 gig HBAs on them. And one of the problems that we've seen is that those 8 gig HBAs can't keep up with the bandwidth on the fabric. And so we start sending more IO to that host off that 8 gig connection than that host can handle. So things begin to back up around queue depth, so they spill over from the server onto the fabric. So now not only do you have a response time issue for that particular host with the 8 gig HBA, but it backs up on the fabric and it impacts other applications that are running. Kind of a tricky thing, especially in large, complex environments, to go in and kind of diagnose and then remediate. So the new tools that we've implemented within Unisphere make it much more easier to kind of figure that out and then figure out, well, what do I do, right? So I want to throttle those 8 gigs back using QoS settings, and kind of what are some of the recommendations around those QoS settings. So helpful there from just a user interface perspective, much more responsive from a Unisphere perspective. Now it's always been pretty good, certainly better than some of the old Java-based interfaces that we were using years ago. But there's definitely a quickness to the to Unisphere 10 that I think people will definitely see. But what I would say is that it's kind of interesting. More and more of the users that I know I talk to, they're using Unisphere less and less, right? And they're going more towards Cloud IQ from a kind of a reporting, dashboard, alerting perspective. And the reason why is because they're not really doing kind of active management on the array anymore. All of that's been automated, right? So now when a user wants to provision capacity, they go to ServiceNow and they say, give me a gold device or a silver device or a bronze device, and that kicks off the calls into the REST APIs through things like Ansible playbooks, where again, now you don't have an admin, having a service ticket coming in and having to create the devices and present those out to the host. It's all been automated, so those things kind of happen. So again, that's why people aren't using Unisphere as much as kind of the central point from a reporting perspective. They'll go in and they'll use it kind of when they have to kind of do kind of these one-off types of things. But the scale, the automation is becoming more of a thing. And that's why this is important, because you see right there, greater rest scale. So within the current Unisphere 9, right, depending on who you talk to, you get a little bit of a variation in terms of the differences. But Unisphere 9 can handle probably 5 or 6 concurrent REST calls, right? So if I'm going in and I'm provisioning devices or asking for reports or doing whatever, I can handle half a dozen or so of these things coming in at a time before the system starts to back up, just because these requests have to queue because they kind of get serviced in order. The new release of this, you're looking at upwards of 100 concurrent requests we can support within the REST APIs. So that radically increases the speed and just the flexibility that you have to do more automation, because you don't have to wait for all these concurrent tasks to complete in order before you can make room for these additional administration tasks to come in. So a lot of work went into that. And again, part of it is just because the overall trend to do more and more automation and to be able to support those types of things happening at a greater level of scale with faster speed to support that. And then on the reporting piece, so there's a whole bunch of cool things that we've done on the reporting side. I think one of the biggest pieces of feedback that we got from our beta sites, customers that were doing kind of the early testing on the platform, is they really like a lot of the things that we did around reporting. They like a lot of the things that we built into some of the help drop downs, right? So they were very contextually aware. So if you saw something and you didn't know what to do, you could hover over it. And now it will actually tell you in a more meaningful way, right, what that particular operation, what it means and what it does. So that helps reduce some of the open tickets and service requests, because a lot of the things, again, are more contextually aware and a lot easier to kind of do on your own without having to have somebody else come in and take a look and ask for some some additional support and some guidance. So whole bunch of things there. Unisphere 10 is required on the new PowerMax platform. It is supported on existing VMAX arrays, with the one caveat being that external management has to be in use for Unisphere. The way Unisphere 10 is packaged within the container, within the code, is done specifically for the new code and kind of the new way we're containerizing the data services on the array. So it won't run, it won't fit on the existing arrays as within embedded management. But if you have external management, you can package that within the VApp, and you can use that to manage the other arrays. Again, not necessarily the new PowerMax, but being able to take advantage of some of the new capabilities within Unisphere 10. So jumping into the hardware, right? So quick look at kind of the architecture, right? So I assume most people are pretty familiar with this, but you know, the kind of the big key to the architecture is this global cache. The fact that you have separate physical cache boards or cache resources across directors in the old system, nodes in the new system, but with the RDMA connections used to connect those engines or nodes, it allows us to treat that as one big pool of shared memory, right? So any connection from any engine or now any node pair can see any piece of media off of the back end, and it allows us to scale that system out linearly. So if I have a single node pair and I add another node pair, I doubled the performance. If I add a third node pair, I triple the performance, and that kind of scales very linearly, right? So that's kind of the basics of the architecture, and that's been the design for many, many, many years. The new generation, so we continue to support from a packaging perspective, two models of the platform. So you have the 2500, which effectively replaces the 2000, and you have the 8500, which replaces the 8000. The difference between the 2500 and the 8500 is basically two key differences, right? One is the number of cores and the speed of the cores that go onto the new nodes, right? A 2500 uses 32 cores, and the cores are 2.3 gigahertz. The 8500 uses 36 cores, and the cores are 3.1 gigahertz. So, you know, node pair to node pair, the 8500, roughly about a 30% faster system than what you would get with the 2500. Again, your mileage will vary. It depends on a whole bunch of things, but just to give you kind of an idea, the 8500 node pairs are faster than the 2500 just because of the components that go on with the chipsets that we're using. The other key difference is the way we scale the system out, right? So the 2500, what you see here is you see the node pair and the media enclosure. The media enclosure is on the top, the node pair is on the bottom. And that yellow line that you see connected the two is an RDMA connection that runs NVMe as a protocol, but there's no external switch. It's basically a direct point to point. So that means I can take a single node pair, I can add a second node pair, and I can connect that over the NVMe connection. That's how I scale that out. The 8500 is different because I have node pairs and I have media enclosures, and those all connect in through the NVMe fabric through a pair of InfiniBand switches. 100 gigabit per second switches are used in order to do that. So that's what allows me to go beyond 2 node pairs in a single system to be able to scale that up to a total of 8 node pairs or a total of 16 nodes to max that out on the 8500. So those are kind of the key differences. The one thing that they now have in common that a lot of people really like is the fact that they both support mainframe, right? So for our mainframe users in the past, to support connectivity using FICON, that required the 8000. It wasn't supported on the 2000. So if you didn't need the performance, if you didn't need a lot of capacity, it was a pretty big starting point for some of those smaller mainframe requirements. The 2500 supports FICON connectivity, so we can support mainframe on that entry-level version of the system. And as you can imagine, taking the switch out, going with different chipsets, that gives us different kind of cost models and pricing approaches between the two models. So one is aimed at kind of the entry point, smaller configurations, less of a performance requirement. And the 8500 would be for kind of larger environments that want to scale out or are looking for, you know, high IOPS in terms of performance. So if I look at the 8500, so this is the way the system would scale. And if I have to redraw the slide because it's actually not accurate, because I'm showing 2 node pairs and 2 media enclosures, and that's not the starting point. The starting point is actually a single node pair and a single media enclosure. So I would just have one on the top, one on the bottom. I did this just because it looks symmetrical on the slide. But now if I want to scale the system out, again, I no longer have to add an engine with 2 directors and 48 disk slots with at least 1 RAID group in it. What I can do is I can add node pairs. If I need more memory, if I need more performance, if I need additional connectivity, I can add those, and I don't necessarily have to add capacity when I do that. And vice versa, if I have plenty of performance, plenty of cache, I just need more drive slots, I can add media enclosures, right? So I have a lot more flexibility in terms of being able to scale the front end out independently from the back end to be able to hit different performance and capacity, or a blend of performance and capacity. Also nice from, again, an upgrade perspective, because now when I need to add, you know, again, more compute from a performance perspective, I don't have to always add another RAID group in order to do that. So there's some good flexibility there. As far as what this would look like in your data center, right? I'm showing a single rack version of this, okay? And in the single rack version, you see the media enclosures on the bottom. And as I mentioned, each of those media enclosures supports up to 48 drives. So I've got four of those. That gives me 192 disk slots. The drive capacities that we support are the 3.84, 7.62s, and the 15.3 drive capacities. If you size a system out, right, and ask for a configuration, if you're over 100 terabytes or so of capacity as a starting point, the sizing tools will almost always put you into a 15 terabyte drive, right? Which is a bit of a change because we were kind of going with the lower capacity media. And the reason why we did that was because of the way we would upgrade the system by adding capacity in a RAID group. We no longer need to do that. We can do single drive upgrades, and I'll come back and I'll spend a second on that. The node enclosed, the node pairs themselves. So in this example, I'm showing 6 node pairs, 12 nodes, but all of that can sit in a single rack, right? The system level max capacity on this is 18 petabytes, all right? So with 15 terabyte drives, I can get close to 18 petabytes with the 192 drive slots. We are qualifying the 30 terabyte drives. Those will be available early next year in the upcoming release. So we'll be going to 30 terabytes in terms of media options in the not so distant future. We have 60 terabyte drives that we're qualifying within the lab. And the reason why that's important is because those 4 media enclosures with 192 drive slots, as we go to the higher density media, you're going to need less of those disk slots in order to get up to the 18 petabytes of system level maximum capacity. So we think based on sizing history for VMAX and PowerMax, the overwhelming majority of large systems that we typically ship will fit into this single rack. If I want to, I could add up to 8 more media enclosures. I could add up to a total of 16 nodes. This, by the way, isn't necessarily how it would be laid out, right? There's some flexibility. We would balance this off and put, you know, maybe more nodes on the rack on the right versus the left. So this is just to kind of show the point that you can add that rack. You can double the amount of drive slots. You can go up to 16, but you can't fit that all in that single rack, right? The 2500 is a little bit different, right? Because now I can start off again with a single node pair and 48 drive slots from a capacity standpoint. System level max capacity is 4.15 petabytes of capacity. So that's writable effective space that you would have in that 5U package. From there, I could add a second node pair, right? So that it would double that up to 8.2 whatever, 8.3 petabytes of effective writable capacity. And if I had a single rack and I wanted to max that out, I could put up 3 systems into that rack, right? So that would be a total of 12 nodes with the associated 6 media enclosures in order to do that. But again, a lot of, 8 petabytes per 4 of these in a single rack. You do the math, you're starting to see some really big changes in terms of the density with respect to the packaging of the system. Now, how do we do that, right? Well, it's through some of the efficiencies. One of the big changes is, this new introduction of what we call flexible RAID. So we've gone away from these static RAID groups of, 3+1 RAID, 4+1 RAID, 7+1 RAID, 14+2 RAID 5, and having to add in increments of RAID groups, to now being able to set the RAID protection and do the striping across the media, and then be able to add single drive options as we scale the system out. So there's from a RAID 5 perspective, we can do an 8+1 and we can do a 12+1. The 12+1 is kind of the recommended one. And again, if you start off with 100 terabytes or so of capacity, it's actually 120, I think is the actual number. That's where the 15 terabyte drives would be configured, and that's where the 12+1 RAID protection would be set. But once that RAID protection is set, I can now extend the capacity and just extend the striping from the current RAID group into the new media that's being added into the system. So I no longer have to add separate RAID groups in order to add capacity out. I just add a single drive and I extend that RAID group. The other thing that's a little bit different is there's no physical dynamic spare in the configuration. What we're doing is we're taking capacity across all of the drives that are contained within the RAID pool, and we're dedicating capacity across those drives as spare space. So if a drive were to fail, which is very unlikely, but if you needed to rebuild a drive, it doesn't go to a single physical drive. It gets spread across the spare capacity across the drives that are already within the RAID groups across the array. And that helps. That's very beneficial for a lot of reasons. The big one is just the performance, and I'll show you what the performance numbers look like. But the new RAID technology does have a lot of flexibility. And the one thing that users like about this is just the scalability that this gives you in terms of how you add capacity. So if I look at this chart, the darker blue line, that's a PowerMax today. That's an 8,000. I'm starting off with 2 7+1 RAID groups. So that gives me a little bit over 200 or so terabytes of capacity into the machine. And then from there, I'm adding another RAID group onto that, which bumps me from 220 or so terabytes up to 325 terabytes. So I have to add things in like these 100 terabyte chunks if I were to use those 15 terabyte drives. With the new design, I'm the lighter blue, so I can start off with again with a 12+1, which are 14 drives as the starting point. So that gives me a starting point of about 225 terabytes, and then I just add single drives. And every time I add a drive, I'm just extending that 12+1 stripe that's already there across the new media. And I end up getting 89% of the effective capacity of that drive. So I add that in, it has the RAID protection that gets striped out across it, but 89% of that capacity is now available for actual user data. So it gives you roughly about 5% more protected capacity per terabyte with the new striping, which again, for larger configurations, translates into a significant amount of available capacity that we didn't have. But again, the significance of this is the fact that we're at 15 terabyte drives today. We'll be going to 30 terabyte drives in the not so distant future, and you'll see 60 terabyte drives beyond. And having to support that media with the requirement of doing capacity adds at a RAID group level is really, really hard. So that's why this is important, because no longer required to do that. From a RAID protection perspective, we do RAID 1, we do RAID 5, we do RAID 6. RAID 5 is still kind of the recommended sort of best practice for most applications, but we do know that some users out there, they want to have protection with RAID 6. to prevent against the potential for multiple drives failing within a RAID set. So we can support RAID 6 as well. You'll see, the differences in terms of rebuilds. It's about half of what it used to be with the new FlexRAID technology. And the difference from a RAID 5, RAID 6, you get this question all the time, it really comes down to performance, okay? And if I wanted to go RAID 6, the one thing I would want to look at is what's the write IO activity look like? If you're doing small block, random write IO, you could see as much as 20, 30% performance impact in having to do the parity calculations. You have to do 2 reads, a calculation, and 2 writes when you go with the dual parity versus single parity, which is a read, calculation, and then a write of the new data with the new parity. So it does add some additional overhead onto that, which is why RAID 5, again, based on the metrics around reliability and just overall availability within the system, and the fact that you're rebuilding a terabyte of capacity in less than 10 minutes, RAID 5 again still is the recommendation, but RAID 6 can be supported if you wanted to add that in. From a caching perspective, so today if I have an engine, I can have a total of 2 terabytes of cache within that engine. Now within a node pair, a single node, I can have up to 3/4 of a terabyte of what is DRAM, and then I can add up to 3 terabytes of additional capacity as persistent memory, and that's per node. So within a node pair, I double that. I'm just under 8 terabytes of basically global memory. So it's a 4x increase roughly in terms of the memory increase. What's different about this is the fact that we are segregating user cache that lives in the DRAM, the highest performance piece of memory. And then what we're doing is taking metadata and now pushing that off mostly to persistent data. A little bit that still lives in DRAM, but all of it really is down on the persistent memory. That's kind of the secret sauce, the magic that allows us to be able to get into all of these high capacity ranges and 64 million snaps and all of that goodness that we can now support, because again, we've increased the amount of global memory. But from an application perspective, we no longer have this single pool of cache that we have to go ahead and figure out, well, what do we need for user data and what do we have to have for metadata management? As that metadata starts to fill up, sometimes you run into situations where you have stranded capacity off of the back end, where you can't create new devices or whatever it is. You no longer have that issue with this because, again, of the way that we're now segregating the memory resources between what's user data and what ends up being the metadata within the system. From a data reduction perspective, so again, the metadata piece has a lot of advantages, but one of the big ones is the fact that we no longer have to do a data reduction preset. So in the past, when we were building a configuration, we want to get an idea of what the expected data reduction would be, and we would set that on the system, and the system would balance its resources based on what that expected data reduction would be. The reason why we did that is because we had a limited pool of cache, and we had to figure out what do we need for metadata and then what's left over for user data, and we need at least some for metadata, and that could limit in terms of what you could do from a scale perspective within the array. This has none of that, right? So there's no DRR presets. When you get 4 petabytes of effective capacity, you get 4 petabytes of effective capacity that you can go ahead and present. So again, some improvements there. Reporting, easier to find out what's reducible versus non-reducible. From a mobility standpoint, so tech refreshes. So I talked about this again. You buy something today, a year and a half, 2 years later, a new version of that comes out. Real easy, very straightforward in terms of the scripts and processes and everything that we now can do in the field to take that version of hardware and replace the nodes and put in the next gen of that. So again, helps simplify the ability to move to the new technology. From a migration standpoint, what we've done here is we've basically taken multiple migration options that we had, and we basically collapsed those down into basically a single workflow, a single user interface that allows you to simplify doing array-based migrations. And ultimately what it is we have a workflow that we created for doing old to new PowerMax arrays. We did this thing called NDM, non-disruptive migrations. And it used SRDF Metro as the transport under the covers to be able to take, the old array's devices, be able to present those old array devices on the new array, because we did this Metro relationship between the two. And then once that was set up, we could use the NDM workflow to do the create, set up all the new devices and the mapping and the masking, the cutover, right, to go ahead and start moving the data from the old to the new, and then the commit, which meant that I'm going to now run the application up against the new system, right, and then tear down the old environment. So very simple workflow that collapsed, 25 or so individual admin steps that were required to do that migration into basically this three-step workflow: create, cut over, and commit. What we're doing now is we're taking that workflow, we're now supporting what used to be known as Open Replicator. It has the basics of Open Replicator, but there's a lot of improvements that have been made to that. So now not only can we use this workflow to go old to new, we can use it to go other to new. So we're no longer limited to having to go old machine to new machine. We can do non-PowerMax arrays that might be in the environment that we want to migrate over. The key difference is that it doesn't use SRDF Metro as the transport, and it uses Open Replicator. So even though we can use the workflow from a host perspective, at some point in time, you have to point the host at the new devices, which means you have to export the old device IDs that were an Extreme IO or a NetApp or whatever that is, to the new devices that are the new PowerMax. So there's some post work that's required to do it, but it does have the benefit of providing a common workflow in terms of what the admin experience would be in terms of doing that migration, right? So those are some of the cool things happening on the mobility side from a security perspective, right? Actually, let me go back one. I want to hit on this one right here. So from a cloud services perspective, so we introduced the ability to do cloud-based snapshots. It was actually in a release that's it's actually over 2 years ago now since we first introduced that. So I could run from the snapshot interface, I could create a snap, and then I had the option, does that snap live on the array? Does it live out on an S3 cloud, right? And then a year later, we introduced the ability to take that S3 snap and to be able to convert it into a block device and to keep it in the cloud, right? So I could hydrate it using AWS and convert it into a block device and then use EC2 compute to run the application. I could do it with a private cloud. So if I had a PowerScale or an ECS, there's a B app that's available that allows me to run that IO without having to put it back on the PowerMax. What's new in this release is the ability to take that S3 and not just hydrate it into any of those clouds, but to be able to restore it back to not just the PowerMax that created it, but to any other PowerMax that supports this capability. So it gives you, again, some additional flexibility for leveraging object stores, cloud providers, and then being able to have different points in terms of where you can restore, where you can run those applications, whether you want to run those in the cloud, whether you want to run those back within your local environment, or a combination of all three of these. Real simple to basically be able to set up. So security. So there's a whole bunch of things that we've been doing around the security front with PowerMax for many years. We kind of target our requirements up against kind of three areas. One is the array itself. The second is the host and app piece of that. And the third is kind of the user or the admin security, right? What's new in this release and part of the hardware for the next gen platform, the 2500 and the 8500, are the chipsets that have hardware root of trust enabled on it. And the hardware root of trust basically allows us to fuse, or it doesn't allow us, it has a cryptographic key that's fused on the hardware, actually fused on those processors. So now as we're doing the initial installation, the initial code load, or any subsequent code loads, patches, ePacks, driver updates, whatever, everything has to now authenticate up against that cryptographic key on the processors themselves. And if they can't authenticate up against those keys, then the upgrade basically fails. It won't happen, right? So it prevents people from modifying things that they shouldn't be modifying and not being able to then authenticate up against that key. And it's really, you know, there's a couple examples of things that we're protecting up against, right? So if you remember a few years ago, on the server side, there was the super micro hack, where let's just say an unnamed entity was able to gain access to the manufacturing facility. And what they did is they went in and they basically added a chip onto the motherboards for these processors that allowed them to be able to potentially have backdoor access to those servers and to the applications running on those servers. So hardware root of trust would prevent that type of a modification because you wouldn't be able to load the code because something had changed. There's also the example of kind of the SolarWinds hack, where the SolarWinds network monitoring technology, an unnamed entity was able to gain access and modify some of the drivers that were being pushed out that gave them the ability to access the networks and to basically be able to access the applications and the data through that network monitoring tool. And again, with hardware root of trust, that would have prevented that type of a hack from happening because that software was modified and it wouldn't be able to authenticate up against the encryption keys on the actual physical hardware themselves. So it's a whole process because now anytime we push an upgrade out, that upgrade, again, whether it's a major OS release, whether it's a, we have new device drivers from the drive manufacturers, and we have to push those drivers out. All of those have to be digitally signed and come directly from Dell manufacturing or a Dell source in order for that to be able to be applied up against the machine. And when I look at this, it's kind of like where sort of encryption started. It feels like 100 years ago, but maybe 15 years ago now, where at the time we introduced encryption and then people started using it, started enabling it. And now, there are a lot of users out there that will not put an array in their environment unless the data is encrypted at rest. So it's become a mandatory check in the box type of a requirement. This whole zero trust infrastructure, this is something that exists in the server space today. So we actually got this technology from the PowerEdge side of the house, where they introduced this long ago, back in the 14G days, which was 2017. So in order to do this, it does take time, right? From an engineering perspective, you have to, this is hardware. This isn't, a software feature that's being added. So anytime you're doing things through hardware, it's a longer lead time in order to get that in, to do the prototyping, and everything that you need to do to take something that's new, a new piece of technology, and get it into the mainstream. So a non-trivial exercise to do that. We've also introduced anomaly detection with Cloud IQ. So Cloud IQ already supports the thing on the right, which is the system health scores. So what we do is we go in, and when you enable this in through Cloud IQ, it takes a couple of days to do the data collection. But what we'll then do is we'll provide you a health score based on the recommended security settings for that storage array, right? And there's like 14 things that we kind of monitor up against. It's things like, if encryption is in the array, did you enable the encryption? Did you change the default password on Unisphere? Did you enable LDAP for admin access? So it goes through all these things, and it'll kind of let you know what you have, and it'll give you a health score of a red, yellow, or a green, depending on how you're set up. What it also does is it gives you an alert. So if somebody goes in and changes something, it will detect that change and it'll put out an alert. Hey, somebody just changed the admin password on Unisphere. Okay, boom, that'll get captured within the new secure the Cloud IQ telemetry. What's new is this ability to do real-time alerting for potential ransomware attacks. And under the covers, what we're doing is we're basically monitoring at the storage group level the data reduction rates, right? So if we see something that is data reducible and historically has trended in a certain way, and now all of a sudden there is a change, an anomaly in the data, in the reducibility of that data, this will go ahead and generate an alert. And what we're looking for is somebody going in and taking a database or an application and now starting to write encrypted data, taking over, maybe some of the files or some of the indexes within those databases and encrypting those as part of the ransomware process. We're looking for that, and we're running this analysis over the course of minutes. So if we start to see something that looks, wrong or just seems to fit that pattern, we'll go ahead and we'll kick off an alert saying, hey, SG23 has this sort of a pattern happening, so you might want to take a look to see. So help identify those things, right, as they're happening before, or at least minimizing the ability for a hacker to do something. The MFA is pretty straightforward. So we're supporting secure ID out of the gate. We have a list of things that we're looking to qualify. Things like the Microsoft Azure authentication tools. There's a thing called Ping Authenticate. So we're kind of building out the list. If you've got something that you're using heavily in the environment and you need us to support that, please make sure to reach out to us, because we want to make sure that we have that on the list and we can kind of track it, because it's really just a question of the roadmap around priorities, which are the ones that users need us to do first. The secure ID was the one that seemed most common, and now we're going in and we're starting to look at qualifying other key managers. I mentioned the snapshot use case. So here's a good example, right? So I go ahead and I create a secure snap. So a secure snap means that I've got a snapshot that is immutable in the sense that I can't delete it either intentionally or unintentionally until that snap expires. Right, so it's a good way of being able to create those snaps and prevent people from going in and trying to kind of cover their footprints by deleting snaps as they're going in and doing something that they shouldn't be doing up against the primary data sets. And this is a very common. This is actually our recommendation for doing a virtual vault on a PowerMax. The recommendation would be to do a 10-minute snap, a secure snap, and to rotate those snaps over 48 hours, 2 days. So you do the math on that, and that means you need 288 snaps. The second part of that is the longer term retention, where you do a snap every hour and you roll that across 7 days. So that adds another 168 snaps. So for each device, just to do this virtual vault, not even the other things that you're doing snaps for, just checkpoints to be able to do a quick crash recovery if something were to happen, you're looking at 400 plus snaps per device. If you look at a decent size array, we often see 5,000 plus devices in those larger arrays. So that requires millions, over 2 million snaps in order to do this use case. So again, that 64 million becomes really important because that's just this vaulting use case. What about all the other things that you might be using snapshots for in the environment? You're offloading backups, doing testing, all those classic snap use cases. So it's a cool thing. Last section here that I want to hit on is kind of what's new within the file space. So as I mentioned, it is a cross-portfolio file technology that we leverage. We're using it within PowerStore, PowerFlex, and PowerMax. So it has a shared set of common capabilities, global namespace. The integration around management is really slick. So it's managed right out of Unisphere 10. It's not like the old ENAS days where you had to link and launch, what was basically Solera Manager in order to manage the file environment. It is completely end-to-end unified within Unisphere. It's also integrated in with Cloud IQ. So if I had file on the older array and I was using Cloud IQ, it really didn't give me any sort of insight or reporting into the file-based data. This does. This now all adds that in. The cool thing that people like about this is the integration around the data services, particularly the SRDF piece. So if you're an SRDF user today, just like I mentioned, and you're using it across the block devices, you're really going to like this for adding it onto the file-based workloads because it has all that same common look, feel, workflow that you've been using for years and years on the SRDF side for block, now extending that into file. So 64 terabyte file system, you'll see in the service release that comes out, will be going to 256 next year. It runs active across all the nodes. It's embedded, there's no hardware. So here you'll see, so I have a node pair and I run active. So if a node were to go offline, I don't have to restart the file system on the other director. That file system will continue to run through the high availability. So it gives us the HA, it gives us additional performance because of the fact we're running active versus what was active passive in the old design. The SRDF replication, again, that's kind of cool, right? So similar to what you're using in the block, you can now extend that into the file piece. And then the cloud, the Unisphere and Cloud IQ integration, that's also cool. I put this slide in just to make sure that I remind folks of one thing, and this is the last slide, is if you're going to look to do file, all right, on day one when this is released, you have to enable file when you do the sizing. So file has to be enabled when you do the installation. You cannot support adding file to an existing system in the initial release, okay? So if you want to use it or if you think you're going to use it, please make sure that we've sized it to support file out of the gate. You will be able to add file to a system that was not set up for it in the release that comes out early next year. So if you didn't set it, but you want to use it in the future, you can go in and you will, within the service release that comes out, be able to add that to an existing system. You'll also be able to disable it. So if you enabled it on day one and then decided, the project went away or there was a change of direction or whatever, you don't have to sit there and dedicate those cores and computes for something that you're never going to use. You can turn it off and you can take the resources and you can add those back into the array. So just an important point to make sure folks know that it's either on or off on day one. And if it's not on and you want to use it, you either have to re-IML the machine and add it, or you have to wait until the service release comes out. So again, architectural strategy, so is my last slide. I lied, this last file slide. So all these things, innovating, optimizing, securing, all of those cool things. This is my last slide. I throw this in here just because it gives everybody the opportunity to reminisce about the first Symmetrics, DMX, and VMAX, PowerMax that entered their lives. So it is kind of cool though, 30 plus years from a platform perspective. There aren't a lot of examples from a technology perspective that go across 3 decades. I mean, I can only think of Mainframe. So, there's a lot of goodness here, a lot of innovation, a lot of history associated with the platform. With that, I'm done.
Scott, thank you so much. That was amazing. We covered a lot of ground. I encourage you to reach out to your Dell account teams to take a specific look at your environment and how this might fit and improve your on-premises workloads. And thank you so much for your time. Really appreciate it. Y'all have a great day.
Thanks, guys.